This, after just rushing through that to finish the last period, this one actually will be very short, and you're going to have most of the period to do the problems. It's really very simple kind of calculation here. And we're going to be getting down, I mean, I think, if you think about it, all the stuff we've done this week has been technically problems. It hasn't been math per se. It hasn't been like you're using your calculator, but it's been problems. They're not stuff that you have to memorize and see in a multiple choice format. I'm going to ask you to write compounds like you did on the quiz here, and you're going to write them. I'm going to give you the compounds, and you're going to write the formulas. I'll give you the name, you write the formulas. But now we're going to go beyond that. Now that we know how to write these, we're going to start doing things with them. We're going to start doing calculations with them. We're going to start doing labs with them. We have 3 labs, I said, in this chapter. I'm not going to do a lab on naming. We're going to do a lab on this stuff that we're going to be doing. And you're going to start having to bring your calculators again because we're going to be using them to do, first off, molar mass. You know, nothing goes away in chemistry. That's the crazy part. You may remember, it's been a couple of chapters now since we've used those numbers in the periodic table down below. Okay? What do we call those numbers? Like 12.011 for carbon. What's that number called? The atomic mass. All right, we used them heavy for like 2 chapters, and then we didn't see them for like 2 chapters, and now they're going to be back. Molar mass is just like the atomic mass. Molar mass is not where Catholic moles go on Sunday. Molar mass. Or on Christmas. Midnight molar mass. Midnight mass for moles. Molar mass. Emily, you're Catholic, for crying out loud.
How do you know that?
I'm just assuming you're Italian, so.
Yeah, I am.
I know. Molar mass is not that kind of mass. It's the kind like that up there, the atomic mass. It's very much like that. Let's do a little bit of review here, okay? If I asked you, well, first I'll give you the definition, then I'm going to do a little review. It's the mass of 1 mole of a compound, okay? That's the definition of molar mass. Just like atomic mass is the mass of 1 mole of an atom. If you don't remember that, you should. We spent, like I said, a couple of chapters using those numbers up there, a lot. And then we went off on a tangent on electrons. It wasn't really a tangent. It was kind of related. And we talked about electrons, the periodic table, and now formulas and naming. Well, we're back. Okay? Let's go back and remind ourselves what atomic mass was. If I asked you for the atomic mass of carbon, for example, 1 mole of carbon weighs what? How many grams? 12.011. Right? It's the atomic mass of carbon. We all would know that. I hope. Where do you see how easy this is? What if I asked you about 1 mole of oxygen? What is 1 mole of oxygen's mass going to be? Look at your periodic table. What is it? 15.999. You see it? Right? It's going to be the atomic mass of oxygen. Well, here comes the $1 million question. What do you think the molar mass of carbon monoxide is? What are you going to have to do? Not average, by no means. Add them. Yeah. Look, if 1 mole of carbon weighs that much, and 1 mole of oxygen weighs that much, and 1 mole of carbon monoxide, carbon and oxygen together, is going to weigh the sum of those two, right? You're going to add them up. Just makes sense. 28.010 grams in this case. Now let's change it up a little bit. What if it weren't carbon monoxide? What if it were carbon dioxide? How would this calculation be different?
You times the carbon.
By 2, exactly. So if it was carbon dioxide, I'd have times 2. I'd have 2, not times 2 of the whole thing, times 2 for the oxygen, and still add up 1 carbon. Exactly. That's how easy this is. That's all I'm doing today, and that's why, although normally when we do problems, new ones, I'll usually do an easy one and work our way in. I only have 1 problem to do because they're all done the same way, and I don't really want to waste your time. You could use the air class got a lot of this homework done. Doesn't look like much. 17 and 19 looks like, oh, only 2 problems. But first of all, these are long. And secondly, they have A, B, C, D, E to them. So they are longer than you think. Okay? So let's just do one example so I don't have to waste your time on this. But here's the actual formula. Let's take a look at it. The formula is molar mass equals the sum of the number of atoms you have times their atomic mass in that compound. So I've got 1 carbon atom and 1 oxygen atom. I just add them up. But if I've got 1 carbon atom and 2 oxygen atoms, I'd have to multiply by 2 for the oxygen and then add them up. And that's what I'm going to show you with a little chart here in a second. when we do our only example we're going to do. Now, you're going to be doing this in the lab on Tuesday. You'll be doing a molar mass. And you'll be using it for a reason. Okay? The more we learn in chemistry, the more we can do in lab, too. That's the other nice part. That's why Chem 2 is generally, despite Bulkley, Chem 2 is generally a better class, a more enjoyable class, because we can do more labs that are of interest than you can in Chem 1, where I'm teaching you most of the basics. You know, like back there, they just finished up a chromatography lab, 2 chromatography labs. They're kind of neat. So you're going to start to see more labs, 2, 3 in this chapter alone, 1 of them before Thanksgiving. All right, let's do our example. Copy this guy down. And guess what else is going to happen as I do this example? I can't do this guy unless I do something I've been teaching you for the past 3 days. What do I have to write out first? About magnesium pernitrate.
The formula?
Exactly. If I can't write the formula correctly, then I can't do this. You actually are going to see the biggest example here right now. So just watch this one and take it. Leave yourself maybe about, how much room? Half a page? Half a page. This is the key to it anyway. Well, you know, that's the other thing about, if you realize how much chemistry builds on itself, if you haven't figured that out already, look, just to do this problem, think about what I have to do. Before I can do this problem, I have to write out magnesium pernitrate correctly, which means I have to look up on the periodic table, which we had a whole chapter learning about, Mg, and write his formula, Mg. I have to know his charge. What's the charge of Mg? What's his charge? +2. I then have to look up pernitrate. And all that we learned over the past 3 days about ternary compounds and the common ion sheet, per, meaning one more than the one on the sheet, I'm going to have to write down, well, NO3 is on the sheet. What's pernitrate going to be? NO4. His charge is -1. And then I've got to balance those two guys out using their oxidation numbers or charges and get MgNO42. Got that? And that's just the first step. And now I've got to do the actual molar mass of him. Now you can see I purposely chose one that would be a little bit more challenging here to do as an example. I don't just have carbon monoxide. I got 1 Mg. How many N's do I have? I heard both 1 and 2 out there. I have 2 N's because there are 2 nitrate or pernitrate ions. So each one of them has an N, that's 2. How many O's do I have? 8. So I want you to show me this in a logical, organized way. So make this chart for me for every one of these that you do. Okay? You're going to have the element, number of atoms, the atomic mass, and the total mass. Okay? Just make that chart. And every time you do one of these, this is the chart you'll make. Now, the fact is, on the homework, I don't expect you have to write this out every time, but you have to show it to me every time. Show me what you're doing here. Okay? For example, element. How many elements do I have? I've got Mg, N, and O. So you write those down. And we have to add all of their masses up. How many Mg's do I have?
1.
1. What's the atomic mass of magnesium? 24.305. And you will be surprised by the time you get done with this year how many of these stupid atomic masses are going to stuck in your head. Equals 24.305 grams. And how many N's do I have?
2.
2 times 14.007 grams. And that gives me 28.014 grams. Hey, guess what we're going to also have to take into account anymore now that we're back to math problems? Significant figures and units. Don't forget either of those things. How many O's do I have?
8.
I've got 8 O's
15.999.
times 15.999. Now, you will need a calculator for that guy. What do you get for that? Actually, you know what? I've got it worked out here, so I'll just tell it to you for now, because you're going to need it for your homework anyway. I believe it's 127.991. 127.99. It actually comes out to be, on your calculator, 127.992. But significant figures say I have to round it off to 1, 2, 3, 4, 5 numbers. 5 significant figures. 1, 2, 3, 4, 5. So that 2 I don't put down. And that makes a difference for my final answer. Because what am I going to do with all those guys right now? Add them up. When I go to add them up, where am I going to have to round my answer off to? Just going to be 2 decimal places. When you go to adding and subtracting, it's decimal places. Multiplying and dividing, it's significant figures. This guy comes out to be 180.31. And there's your answer. And that is the molar mass of magnesium pernitrate. And you got to do that.